Hello and welcome to this video on modeling and solving problems involving quadratic equations. So in this video I have taken a couple examples of word problems, application problems from an intermediate algebra text. In one of the problems we are actually given our quadratic equation model, a quadratic function as a model for the situation being described, and then it has a couple parts that I have to answer where in each part we'll be setting up a quadratic equation and solving said quadratic equation and answering the question. And then in my second example we are not given a quadratic model to start and we have to make our own. We have to make a diagram of the situation and set up our own quadratic equation, which is very often what usually happens in a word problem or an application problem. You're just given a description of a situation, and then you yourself, through the use of the keywords in the problem and information from the problem, you yourself have to set up an equation or an inequality or a system of equations on your own to help you answer the question that's being asked. Okay, so the first example I have, and I pulled this from an intermediate algebra textbook. So this actually this example might be a bit dated or will soon be dated. I have the revenue R, right? So capital R is a variable representing revenue. Revenue is the money that's brought in, right? Money brought in, money gained, that's revenue. So the revenue R received by a red box kiosk, right? You don't have to know what this is to be able to go through this problem, but if you've ever gone to like a Walmart or a Meijer or some other grocery store, very often by the customer service area they have these red box kiosks that you can rent DVDs from and return them to. So the revenue R received by a red box kiosk renting X DVDs, right, digital versatile discs. Again, this might be dated in a little while, right? Who watches DVDs anymore, right? Most things are streamed, but again, you don't really have to know what these are to be able to answer these questions. So renting X DVDs per day. So X will be a variable representing the number of DVDs that are rented from this red box kiosk in a day, and R will represent the amount of money that's bringing in for that kiosk. And the revenue after renting out X DVDs is given by the following function. So R of X, right, this is that function notation. Remember where the X, right, the variable inside the parentheses, this is called, this is the input variable or the argument variable. I've put up other videos on function notation. And then R of X, right, R of X, this is the output. Right, or you could just say R is the output or the name of the function. And then over here on the other side of the equal sign is how the output is calculated given an input of X. So how the output is calculated. Alright. So how it is calculated is, I take the input X and the revenue R will be equal to negative 0.005 times x squared plus 4 times x. Alright, so negative 5 thousandths times x squared plus 4 times x. Alright, so the first question, I have two of them, and they're very similar. So how many DVDs must be rented in order for the revenue to be $600 per day, right? So the question is, how many DVDs must be rented? So that means, they don't know X, right? Because remember, X represents the number of DVDs rented in a day. So if they're asking how many DVDs, they don't know the value of X. But then later they're saying we want a revenue to be $600. So R equals 600, right, or $600. So they're giving us the output. They're giving us the output, the revenue, $600. So you can say R equals 600, or R of X, because they wrote it as R of X equals 600, same thing. So they're giving us this output, this revenue, and we're asked for the input, right? We're asked to find this value of X, this number of DVDs. Alright, so I'm just plugging those things into my function here. So the left side, this entire left side, the R of X, that's the output, that's the revenue. So that side's going to be 600 equals, and then the right side, how the output's calculated, has the inputs of X. I do not know these X's. So equals negative 0.005 times X squared plus 4 times X. Right, I just leave it the way it is because again I don't know the value of X, and then we're solving this quadratic equation. Right, and then of course checking our solutions when we're done, seeing what solutions actually make sense for the problem in question. Okay, so what I'm going to do to start is I know very often people don't care for having decimals or fractions in equations, and so what I'm going to do right now is I'm going to multiply both sides by a number so that that number is gone, the decimal is gone. And remember, for decimals, you can multiply by a power of 10 to move the decimal points. Okay. But I'm going to do something a little different. All right, let's think of that as a fraction. This is 600 on the left. And then this is 5 thousandths, 5 over 1,000. But what's 5 over 1,000 when you reduce it, right? 5 goes into 1,000 200 times. So this is negative, 5 thousandths as a fraction that's totally simplified is 1/200th. That's the same thing as 5 thousandths times X squared plus 4X. All right, and then remember with fractions, if you want to rewrite an equation so that there are no fractions, multiply by the LCD. Right? The least common denominator here is 200. Right? That's the only denominator other than 1. So I'm going to multiply everything by 200. Right? This entire side, right? Just the 600 times 200. And then this entire side, so there are two terms. So there's going to be some distributing, right? I'm going to have to be distributing 200. And multiply both sides by this 200. So on the left side, 6 times 2 is 12. And then you have, 1, 2, 3, 4 zeros. So, the left side is 120,000, right, when I multiply by 200. When I multiply this one by 200, right, 1 over 200 times 200, right, that's the whole point of multiplying by the LCD, is so that the 200s cancel, and I'm left with just the negative 1 times x squared, or negative x squared. Then plus, and then 4x times 200 would be 800x. Okay, so here's a nice, this is the same equation. Right? This equation I started with and this equation here are the same equation. I just multiplied both sides by 200. Alright. Next, I can solve this in, there's lots of ways to solve quadratic equations. And I'm going to do a method called completing the square. Alright. So again, you can do whatever you want. You can, you can put it in standard form, right? Get everything to one side, and then solve it with the quadratic formula or by factoring. Right? There's other ways to solve, but I'm going to solve by completing the square. Now remember, to complete the square, so I'm using completing the square, right? You choose whatever you want. Now remember, to complete the square, you have your variable squared term, and then your variable to the first term on their own side, and then the number, the constant on the other. And the coefficient on the squared term had to be 1, positive 1. Well, right now it's negative 1. So all I'm going to do now, just to fix that, is divide everything by negative 1 or multiply by negative 1. Same thing. So the first thing I'm going to do is divide by negative 1 on both sides. Alright, and that'll give me on the left side. And actually I'm going to switch the sides as well to have my variables on the left and non-variables on the right. So when I divide this side by negative 1, you'd have, positive x squared. And again, I'm just moving it to the other side. And then when I divide this by negative 1, it'd be minus 800x. Okay. And then what we're going to do is complete the square on this, right? We're going to add a third term so that there's a perfect square trinomial. Right, 3 terms that can be factored as a perfect square, written as the same factor twice. So I'm going to leave a little space, right, a little space here to add our third term, complete the square, equals, and then the other side, right, divided by negative 1. So this other side now is negative 120,000. Okay. Now here comes the completing the square part. Right. Remember how that's done. Once you have this, coefficient of the squared term is 1 plus some number times x, that number is negative 800. Remember, you take half of this number, which is negative 400, and then square that. Well, negative 400 squared, right? Negative 400 times negative 400 would be positive, right? So I'm going to be adding. Then 4 times 4 is 16, but you'd be adding 4 more zeros, right? 400 times 400 would be 160,000. And I'm going to be adding, and don't forget it's an equation, right? I'm adding 160,000 here to complete the square, make a perfect square trinomial. I'm going to do the same thing to the other side to keep it balanced. Okay, so now I have on the left side a perfect square trinomial. Right, this x squared minus 800x plus 160,000, that can factor to the same factor, twice. It's the variable x plus whatever half that number was before you squared it, right? Half of the negative 800 times the x to the first, that was negative 400. And go ahead and check, if you want, take x minus 400, multiply it by x minus 400, do all the foiling and combining like terms, you'll indeed see that you get x squared minus 800x plus 160,000. And then on the other side, I have, negative 120,000 plus 160,000, that's positive 40,000. And then I can use what's called the square root property. If you recall, again, look up a previous video on solving an equation, a quadratic equation by completing the square, or solving by the square root property. By the square root property, because I've got a square equal to a number here, either x minus 400 equals the positive square root of 40,000, or this base, right, under the square, the x minus 400, is equal to the opposite of this, negative square root of 40,000. All right, well, 40,000 is another nice square. It's actually 200 squared. 200 times 200 would be 40,000. So we have on the left equation, x minus 400 equals 200, or x minus 400 equals the opposite of that, right? Negative 200. Right. So if I add 400 to both sides here, we get x equals, when I add 400, that'd be 600. Right. Or adding 400 to both sides here, we get x equals 200. Right. And then check them, right? Don't forget to check them. Alright, so going back to the original equation that we set up, right, that was this here, 600 equals negative 0.005 times x squared plus 4x. Let's see if these numbers work in there. Right? So you could plug them in by hand. I'm just going to do them real quickly off to the side here with the calculator. Alright, so we have let's go, now the left side 600. Let's punch them in the right side with the variable and see if we get 600. So negative 0.005 times 600 squared, or I'm checking the first solution, 600. Then plus 4 times x, right? 4 times 600. And I'm getting 600, right? So 600 equals 600. This is a good solution, 600 for x. The other one was 200. So negative 0.005 times 200 squared plus 4 times 200, and that is also 600. So both are good, and they both would make sense, both these numbers. All right, so again, don't forget to, I'll write check here, right? Both are good, all right? Both work out in the original equation that I set up. And they're both positive numbers, right? They both make sense as a possible number of DVDs that could be rented out of this red box kiosk. So the question is, how many DVDs must be rented in order for the revenue to be $600 per day? There are two possible answers here. If the kiosk rents 200 DVDs, the revenue will be $600. Or if the kiosk rents 600 DVDs, the revenue will be $600. All right, so the way I'm going to answer this question, right, and the way you should answer any question when you're dealing with a word problem, is with complete sentences, and also every time you have numbers, you throw units on those numbers to give them meaning. All right, so the way we're going to answer this so in order for the revenue to be $600 per day, the kiosk must rent out either, right, because again there are two possible solutions here that we saw, either 200 DVDs or 600 DVDs. Again, notice complete sentence, and every number that was mentioned had units attached, right? $600, 200 DVDs, 600 DVDs, right? So that the numbers actually have meaning. And these are both good possible numbers. These are positive numbers. Now, if I ended up with a negative solution, I wouldn't consider that one, right? Because how can you rent out? How can you rent negative DVDs? What does that even mean? But 200 and 600 are both reasonably, they make sense, right? They're reasonable numbers. You can rent out any positive whole number amount of DVDs, and that would make sense. Okay, so there's part A, and part B is very, very similar, right? In fact, I'm going to do exactly the same thing basically. Part B is the following, same question, right? But now part B is how many DVDs must be rented in order for the revenue to be $800 per day. So not much changes here except for the revenue, right? So R of X, or just R, equals $800. That's what's given to us. And then again, the question is how many DVDs, right? So they don't know X, right? So it's exactly the same as last one, but the revenue now is, I want the revenue to be $800 instead of $600. Alright, so we go back into our function here, our equation up top. R of X, so the revenue, the output, is 800, so that'll be this side. And then, X I don't know, so the other side, how the output is calculated, will not change. So here's the equation. 800 for the R of X equals, and then the other side, right, negative 0.005 times X squared plus 4 times X. Right, and we're going to be solving this equation for X, and then of course checking our solutions and seeing if they actually make sense for a number of DVDs to be rented. Alright, well, just like last one, right? Remember the last equation, I multiplied both sides by 200 in the beginning because this negative 0.005, this is negative 1/200th. So I'm going to do the same thing here. Right, I'm going to multiply both sides. So I'm going to take the 800, I'm going to multiply it by 200, and same thing on the other side. This whole side, the negative 0.005 x squared plus 4x, multiply that by 200 as well. So I mean there are multiple terms, so you're going to have to distribute. All right, the left side, is 16. This is going to be 160,000. Right, 2 times 8 is 16, then you'd have 4 zeros. Right. Then on the right side, the 200 times the 0.005, that's 1. But I have this negative here, so it's negative 1x squared. And then 200 times 4x would be 800x. All right. Okay, so just like last time, only the number on this side is 160,000, right? It's very similar. And just like last time, I'm going to solve this by completing this square. All right, you can do another method if you want. Quadratic, get it in standard form, use the quadratic formula, or get it in standard form, solve by factoring if you can. But I'm going to use that completing the square again. So just like last time, I'm going to divide everything by -1 so that I get the coefficient of the x squared to be +1. Right? I want the coefficient of the x squared to be +1. Alright, so if I divide both sides by -1, this side will be x squared, and again I'm switching the sides. X squared, then minus 800x, and since now the coefficient of the x squared is 1, I can complete the square, so I'm going to be leaving some space here for that third term I'm going to be adding on to make a perfect square trinomial. So I leave some space, and then equals, and then dividing this side by -1 is negative 160,000. All right. Now comes the completing the square part. Remember, I take half of negative 800, which is negative 400, square it, be positive 160,000. And I don't forget this is an equation, so I would add this to both sides. Then comes the factoring, right? This left side is now a perfect square trinomial. So I should be able to write that as a perfect square. And that would be, again, x minus 400 to the second power, just like last problem. But this time, right, the number on the other side is 0. And look at this. This is some number squared equals 0. Well, there's only one number that when you square it, you get 0. And that is 0. So the only way this is true is if this base here, this x minus 400, if that's 0. Or you could also use the whole square root property and say x minus 400 is the square root of 0, which is a 0, or x minus 400 is the negative square root of 0, but that's also 0. So you'd be getting this same equation twice, meaning we're going to have that single repeated root, right, or that one repeated solution, and that's going to be 400, right? If I add 400 to both sides, x equals 400, and don't forget to check it. Right. So going back to the original equation, right? The original equation looked like this. The left side's 800, and just to save some time here, I'm gonna put this in a calculator. Pop it on the right side. I'm gonna put 800 in for x. 400 in for x. So I have negative 0.005 times 400 squared, and then plus 4 times 400, and that is indeed 800. You'd have 800 equals 800. 400 is a valid solution. And does it make sense for the problem? Well, yeah, it's a positive number. It's a nice whole number, and the question was how many DVDs must be rented, right, to get this revenue out of $800. So, I mean, renting 400 DVDs sounds like a reasonable thing, right? That could happen. Right. So finally I'm going to actually word the answer to that question. Alright, so again, word problems, application problems, please, answer your questions, complete sentences, and have units on your numbers so that it gives them meaning and they make sense. So, I could word it this way, just replace, there's only one possibility here, not two like last time, so I'm going to say 400 DVDs must be rented in order for revenue to be $800 per day. Again, notice, complete sentence, and every number has units. 400 has, DVDs. 400 what? 800 has dollars. Right? So that things have meaning, things make sense. Great. All right. So that first problem, right, this first example with these couple questions, we were given the quadratic function model for the problem, right? We were given this revenue equation here. That's not always the case, and you know that, right? When you're usually solving a word problem, very often you have to set up an equation or a function or an inequality or a system of equations. You have to set something up usually yourself from the information given. All right, so that's what my last example in this video is like. All right, so take all this away. All right. This last example is, again, another problem I've pulled from some intermediate algebra text where a quadratic equation will come into play while solving it. So I have a rectangular plot of land is designed so that its length is 14 meters more than its width. The diagonal of the land is known to be 34 meters. What are the dimensions of the land? All right. So I'm going to draw a little diagram here. They say it's a rectangular plot of land. So this isn't perfect, but here's a rectangular plot of land, this area. And again, imagine this is actually a rectangle with 4 90-degree angles. I'll put those little 90 degrees in there. And it's going to have a length and a width. Now, based on the sentence, the first sentence, it said the length is like more than the width. So I'm going to call this one that looks longer in my picture the length of the rectangle, and the shorter looking segment in my picture, based on my drawing here, call that the width of the rectangle. And these are the dimensions. All right, when they ask what are the dimensions of the rectangle, the dimensions of the land, they're asking you for the unknown quantities, the length and the width of this rectangle. All right, so as with any word problem, you read through it and then you ask yourself, what do they want from me? What don't I know? Well, we don't know the length and we don't know the width. Okay, so call them something. Now you could use multiple variables. It's just you got to be careful, right? The more variables you introduce, the more equations you're going to need to write to be able to rectify the problem. So I'm going to try to keep the number of variables to a minimum. In fact, I would like to only have one variable, right? Because we've been solving quadratic equations in this video and in previous videos. We've been solving quadratic equations involving only one variable. So notice the first sentence, right? A rectangular plot of land is designed so that its length is. Remember, length is, I'm going to call length something, is. Usually when you see is or are or was or were, some version of the form of the verb to be, it usually implies there's an equation going on, an equals. And then look at this other side, 14 meters more than its width, right? More than, implying that I'm adding 14 meters to the width. Okay, so I could call, see how length seems to depend on width, right? They're saying length is something to do with width, or you could also say that length is a function of width, depends on width. So I'm going to actually just call the width a single letter, right? I'm going to let the width be, say, W for width. You could call it X if you want, doesn't matter. And then the length, there's an equation right here. The length is, so the length equals 14 meters more than its width. So what was the width? That was W, but then the length is the width plus 14, right? Hopefully that makes sense, right? The length is, and then W plus 14 is this 14 meters more than the width. So you see I've set up my expressions for these two unknowns. The width is W and the length is 14 more than that, W plus 14, with just a single variable, right, the W. Okay. Now that's using information from the first sentence, but we were also given another piece of information, right? We were told that the diagonal of the land is known to be 34 meters. Now what is a diagonal? Well, for a rectangle, right, a diagonal is just from one corner straight across to the other corner. Right? It's going across the figure diagonally. Right? So this is a diagonal. And in fact, a rectangle has two diagonals, but something you might know already about the diagonals of a rectangle is that they're congruent, they have the same length. So I'm just going to draw this one, right? The other one would have the same length. And they're telling us the diagonal of this land, the diagonal of this rectangle is known to be 34 meters. I'll just put the little m for meters. But 34. Great. Now I have a diagram, a little picture of what's being described up here. The question is, what are the dimensions of the land? Well, in order to find the width and the length, I need to solve for W. I need to find W, right? This thing I call W, by setting up some sort of equation. So where do I see an equation that could be formed here? All right, well, as with a lot of word problems, some outside knowledge is going to come into play here. Something that's not even mentioned, but something that you're assumed to know is going to come into play in this picture. Do you see the right triangle here? if I go from this upper right corner to the lower left corner, and then draw the length, and one of the lengths, the length across, and then the width of the rectangle, basically cut the rectangle in half, I get a right triangle where this leg has a length of W, right? W meters, because everything's, I mentioned meters. This leg, the length, has a length of W plus 14 meters, and then the other length, this side, right? Remember, this is called the hypotenuse, right? The side that's opposite the 90-degree angle, and that's 34 meters. That was already known. And if you're looking at a right triangle and want to set up an equation involving the lengths of all the sides, that's where the Pythagorean Theorem comes into play. All right. So I'm not going to go on a whole page or a whole discussion of the Pythagorean Theorem. Again, you're kind of assumed that it's kind of assumed that you know what it is. And I've done a video on the Pythagorean Theorem before. If you want to or look for other people's videos on the Pythagorean Theorem, do a quick search. But the Pythagorean Theorem states that if you have a right triangle, like I do here, you can set up an equation involving the squares of the lengths of the sides. And that equation will look like the following. All right. By the Pythagorean Theorem, I've got a right triangle here. You take one of the legs. Now the legs are the sides that form the 90-degree angle. So if you take one of the legs, W, and square it, then add to that the square of the other leg, right? So the other leg, this quantity W plus 14, take that length and square it as well. So this is the sum of the squares of the legs will be equal to the square of the hypotenuse, the square of the lawn side, the side opposite the 90-degree angle. So that'll be equal to 34 squared. And then what we have here is a quadratic equation. All right. So let's go about now we're solving this equation for W. All right. So I'm going to try to get this in the standard form for a quadratic equation, where I take everything to one side and 0 on the other, and we'll see what happens. Right? See if we can solve it by factoring, or maybe with the quadratic formula, or completing the square, or whatever. All right. So we have W squared plus. Now remember, this is W plus 14 times W plus 14, and then I got a FOIL. Right? This is not W squared plus 14 squared. You do not distribute powers. You do not distribute exponents. So I'd have W times W, which is W squared, then W times the 14, which is 14W, and then another 14 times W, 14W, and 14W would make positive 28W. And then 14 times 14, right, 14 squared would be 196, positive 196. All right, and then on the other side, 34 squared, you can do, set up 34 times 34 the long way, or, or punch it in somewhere. This is 1,156. Okay. 34 squared, 34 times 34. All right. So combining some like terms, I have, here 2W squared plus 28W plus 196 is equal to 1,156. All right. Now, before I move on any further, one thing I do notice that will make the numbers a little smaller. Look at all the terms on both sides. They all have some even number factor, right? 2, 28, 196, 1,156. They're all even. So I'm going to divide everything by 2. just to get rid of that common factor of 2 that everybody has. And that'll make all the numbers smaller and hopefully make this easier to deal with. So dividing the first term over here by 2, we have, just w squared. This one, 28w divided by 2 would be positive 14w. And then dividing 196 by w would be 98, right? And then 1156 would be 578. Right. And then, okay, now I know I said I would put it in standard form, but looking at it now, I'm seeing a very nice, easy equation to solve by completing the square. Notice I have my 1w squared, which is great, plus, and then a nice even number times w to the first. Now that'll make completing the square real easy. So I'm going to do this instead, get my w terms on one side so I can then complete the square. And let's take away the 98. Alright, so now I have on the left w squared plus 14w. Of course, leave a little space. I'm going to leave some space so I can complete the square. Equals, and then 578 minus 98 would be 480. Right. Yeah, 480. Great. Now completing the square, we have the 1w squared like we want. Take half of 14 is 7. Right? 7 squared is 49. I'd be adding 49 to both sides, not 449. Sorry, ignore that blob. This is just 49. Right? And I'm going to add 49 to the other side as well. And once you add the 49, right, once you've completed the square, remember this is now a perfect square trinomial. You should be able to write this as the same factor twice. So this w squared plus 14w plus 49, that should factor to w plus 7, right, the variable plus, whatever half of that 14 was squared, equals, and then 480 plus 49 would be 529. Alright, now 529, if that's a perfect square, that would be wonderful, and it is. I'm doing a calculator off to the side here, sorry. The square root of 529 is 23. Alright, I have an equation now where I could use that square root property. Right? If w plus 7 squared is 529, then w plus 7 is either the square root of 529, or w plus 7 could be the negative square root of 529. And as I said, off to the 529 is actually 23 squared. So we have w plus 7 could be the square root of 529, 23. Or w plus 7 could be the opposite of that, negative 23. And I solve each of these for w, and then of course we'll check them. Here I would subtract 7 from both sides. We get w equals 16. Or, and same thing over here, I'd subtract 7, w equals negative 30. And don't forget to check your solutions back in the original equation. That was back here. Right, when I set up after the Pythagorean Theorem, this w squared plus, w plus 14 squared equals 34 squared. Well, let's see. Now, I already said 34 squared, right, is 1,156. Right, 34 squared is 1156. I'm going to punch in my calculator on the other side, 16 for w, and hopefully we get 1156. So, 16 squared plus, and then the quantity, 16 plus 14 squared, or 30 squared, that is 1156. Great. So 16 is good. And negative 30. you know, so in parentheses, negative 30 squared, right, the w squared, plus, and then in parentheses, you know, negative 30 plus 14 squared, and I'm getting again 1156. So this is good too, but you know, you got to be careful, right? Just because some numbers satisfy the equation you wrote doesn't mean they make sense for the problem, right? Do they make sense in the problem? Because think about what the problem was, right? Here's my diagram. We were talking about a rectangular plot of land. We were talking about lengths. Remember, W was the width of this rectangle in meters. So having a width of 16 meters actually makes sense. Right? That's a positive quantity. Length is a non-negative quantity. Having a width of negative 30 meters, that doesn't make any sense. How can you have a negative width? Right? So yes, this is a solution to the equation I wrote, but it doesn't make sense with the problem. So I'm going to eliminate negative 30 as a possibility. So the only one that does make sense for a length and a width is the positive 16. Alright, now you might think that you're done, right? I know that was a lot of work, but you're not. Right? We're not done yet, because we have to answer the question. Right? What are the dimensions of the land? And as I've said before, you should also be answering, you know, word problems and application problems with complete sentences and units on your numbers. So just circling W equals 16 isn't the end. So the way I would answer this, you know, we have W as 16. Remember, W represented width right here. So I'd say the width of the rectangle, or just the width, is, you know, 16 meters, right? All the lengths in the problem were given in meters. The width is 16 meters, and the length of the rectangle, or the other dimension, is, now don't forget, it's not 16. Now you can plug 16 now in for W. Remember, the length was W plus 14. So the length will be 16 plus 14, or 30 meters. And there you go. That's a complete sentence, complete thought, and every number I've mentioned has, you know, a unit on it to give it meaning, right? The unit of meters. And even double check that, you know, if I made a rectangle, here's this rectangular plot of land, again, not a very good rectangle. You know, if this was 16 meters and this was 30 meters, right? 16 meter width, 30 meter length, would the diagonal, right, be 34 meters? Well, yes, it would, and we've checked that. I've seen that before, right? 16 squared plus 30 squared is going to indeed be equal to 34 squared. All right, yeah, you have the right triangle here, satisfies the Pythagorean theorem. So yes, it seems to work out. All right, it looks like it works. But always check your answers. Always make sure that what you're writing down actually means something, actually makes sense before you hand it in, or before you submit it as homework, as a solution. Alright. So I like to say at the end of these videos, do the best you can. Try and learn the material on your own before you go looking for help. So I've found over the years that, you know, when people take the time and the effort to learn something on their own, they tend to remember that material for longer and remember it better and are more proud of themselves. So of course, you know, read the material, read through the author's examples, Perhaps even work out the solutions to an author's examples before you see how the author did it, and compare your work with the author's and see if you can learn from some mistakes there. Obviously do tons of exercises, practice problems, check solutions to those if they're made available so you can see your progress, check how you're doing. And don't give up on a problem after just 1 or 2 attempts. Don't give up so easily. Very often in mathematics there are several approaches that'll work for any particular problem. So if after several approaches, several attempts, you're still having trouble, I would suggest you go back and read the material again, maybe even a 3rd time, more slowly, more deliberately. Take good notes. Because if you've been working on problems as you should, there's a good chance that you have a better idea as to what the author wants from you, what the author expects of you in that section. You'll know more about what's considered important by the author. So then you can go back and, when you read again, or that 3rd time, you'll be able to pick out those important things more easily. And perhaps even things will pop out at you and be revealed to you that you didn't catch the first time through. And it might shine more light on the subject, make it even easier to work on the problems. But if after that, if after several read-throughs of the material and several attempts at the problems, if you're still having trouble, it's not a sign of weakness whatsoever to go out looking for help. That is what other people are there for, to help you. So ask a teacher, a tutor, a friend, someone in your class who knows the material well and is willing to help. Look for supplemental materials online. There's loads of it out there. Look for videos online. There's tons of those too. Videos like this one, or plenty of other ones out there that are better than this one. I assure you they're out there and they're easy to find. But just keep at it. Stay persistent. Keep practicing. Don't give up. And above all, and I think this is the hardest thing for most people, is to stay positive. Try to have fun with it. Believe in yourself and your abilities through your struggles and failures and frustrations. Because it's in those moments when you're struggling and failing and are frustrated and making mistakes, it's in those times that you can learn the most deeply and learn the best. Because if you persist, you persevere, you make it through and learn how to fix your mistakes, even through that frustration, you stick to it and learn how to fix your mistakes. You'll remember that material for far better and far longer than someone who got it right the first time and just breezed through it and never gave it a second thought again. Okay, so stay persistent, keep practicing, stay positive, and don't give up. And I just know you'll get it. And thank you very much for watching.